What if I told you the beech tree, sitting quietly in your backyard, is actually doing complex calculus right now? I mean, you're out there dragging the patio furniture onto the lawn on the first sunny weekend, but that tree is running this strict mathematical survival protocol.
It really is.
All right. So today's deep dive is all about this invisible biological math. We're combining some, well, highly entertaining observations from two friends, Kesser and Steen, with the forestry research of Peter Wohlleben to see how trees literally count the sunbeams to survive.
The contrast is honestly pretty hilarious when you think about it. Kesser and Steen were just watching this classic spring phenomenon where city folks get hit by like one warm Saturday and go completely crazy.
Yeah, frantically raking and styling the summer house gardens like absolute maniacs.
Exactly. And Steen actually joked that he wished they had that kind of manic energy back in January, when the snowy sidewalks needed shoveling.
Right, where were they then?
Yeah.
But the humor here is really the juxtaposition. We humans feel a 60-degree breeze, and boom, we immediately think it's summer.
Oh, for sure. Meanwhile, Kesser points out that the beech trees around them are just completely unfazed by a random warm afternoon. They're just waiting.
Okay, let's unpack this, because here is what I really don't get. A tree obviously doesn't have a nervous system,
No, definitely not.
let alone a watch or a calendar. So how does a blind, completely stationary organism physically measure time?
Well, Wohleben's research points to chemical sensors right inside the buds themselves. It's not just a matter of, feeling warm.
Wait, so what are they feeling then?
It's light. The buds contain these light-sensitive compounds that actually react to the length of daylight. So during the winter, those chemical signals are basically dormant.
Okay, making sense so far.
But as the days get longer, a very specific light-sensitive molecule just steadily accumulates inside the bud.
Oh, so it's sort of like a biological hourglass filling up.
That is a great way to visualize it, actually.
Right.
For a beech tree, that hourglass has to fill to a super specific threshold, which is at least 13 hours of continuous daylight.
Wow, 13 hours exactly.
Right. Until that chemical concentration hits the 13-hour mark, the bud just remains firmly locked.
So the tree just totally ignores a random 70-degree day in February.
Completely ignores it. Because the light accumulation simply isn't there yet, and that prevents a catastrophic loss of all their new buds to a late frost.
Here's where it gets really interesting, though. If this chemical hourglass is a hard biological rule for the whole species, Kesser and Steen's observations don't totally add up.
How so?
Well, they noticed that one side of a road might be blooming, right, while the opposite side is just totally bare. If every beech needs exactly 13 hours, shouldn't the entire forest pop at the exact same moment?
Well, that assumes the entire forest operates under identical conditions and identical genetics, which, just isn't the case.
I see.
What's fascinating here is that you have to consider the risk-taking strategy of the understory. The young trees down on the forest floor are dealing with totally different survival pressures than the canopy giants above them.
Right, because they're about to be plunged into total shade the second the mature trees leave out.
Exactly. So they accept a massive risk. These younger trees are actually genetically programmed to bloom about 2 weeks earlier.
Oh, just to gorge on that unfiltered morning sunlight.
Yeah, they have to. They accept the much higher probability of frost damage because, well, starvation from canopy sheeting is basically a guaranteed threat.
That is incredibly smart.
It is. And add to that the concept of provenance, which is the specific genetic origin of a tree. Even in the exact same stand of trees, genetic diversity means some individuals have a slightly altered chemical threshold.
Meaning they spread the risk around so a single late freeze doesn't wipe out the entire next generation.
Precisely. It's an insurance policy.
Okay, that evolutionary efficiency makes total sense. But it still leaves this bizarre quirk I've definitely noticed with younger beech trees.
Leaves. Right.
Yeah, mature beeches drop their leaves perfectly in the autumn. But if you look at a young beech hedge in a city garden, it just clings to these dry, brown, rattling dead leaves all winter long.
It looks like the tree just got lazy and forgot to finish the job.
Exactly. Why the laziness?
Well, that incomplete job is actually a deliberate defense mechanism. In a mature tree, autumn triggers the creation of an abscission layer.
An abscission layer?
Yeah, basically a clean cellular break right at the base of the leaf stem. Young beeches, however, intentionally halt that process. They don't form the complete break layer.
So they just stubbornly hold on to the dead foliage just to act as a winter coat against the wind or something.
That's part of it, sure, but it seems energetically wasteful until you realize it's highly efficient armor.
Wait, armor against what?
Hungry deer. Those dead leaves are stripped of all their nutrients, making them a really terrible, noisy, unappetizing meal for browsing deer.
Oh, wow. So it's basically a bunch of dry, gross wrappers hiding the good stuff.
Exactly. By keeping this armor in place all winter, the tree physically blocks herbivores from reaching the dormant, nutrient-rich buds hiding underneath.
That is wild.
And they don't expend the energy to drop the leaves until spring. That's when the swelling of the new growth physically ruptures that old stem connection and just pushes the dead leaf off.
Man, it fundamentally changes how you look at a quiet forest. I mean, these aren't just passive background objects waiting for a nice day.
Not at all. They are executing a deeply calibrated strategy, balancing chemical thresholds against genetic risk and physical armor.
It is just a remarkable system of patience and precision honed over millennia. So what does this all mean? It means the trees in your garden are risk-taking, calculating strategists.
Absolutely.
Which leaves us with a rather urgent question for you to ponder. If a tree's survival relies on this incredibly delicate ancient chemistry of counting exact daylight hours alongside temperature thresholds, how will those internal hourglasses cope as our global temperatures become increasingly erratic and unpredictable? What if I told you the beech tree, sitting quietly in your backyard, is actually doing complex calculus right now?